Hello, my name is Tony Afshary from Seagate. We are here at Flash Memory Summit 2016. I'd like to tell you a little bit about our products, some building block products we call them, which for the most part are SSDs or add-in cards, but also tell you how they are being deployed in real systems and what challenges they face and how we solve some of those problems. So to start with, I'd like to talk about the fastest product SSD in the market. Here's a 10 gigabyte per second SSD by 16 add-in card, which is the world's largest or fastest production SSD. We have the largest capacity SSD in the world that we're demonstrating. It's a whopping 60 terabytes of flash, largest in the world. We're also showing the densest SSD in the world. This is a production enterprise class 2 terabyte M.2 NVMe drive. So one of the interesting opportunities and deployment scenarios for putting NVMe in a system is something that Facebook is doing. This is a lightning tray. It's what they call a JBOF. They're not the only ones that refer to this term. It's just a bunch of flash. And for their reason, what they're doing is they're disaggregating storage away from compute so that they can scale each one of those separately in their rack. With this particular solution, so in this model, what they're doing is once they disaggregate storage, it's all NVMe. So and they use a switch fabric, or not a fabric, just a straightforward switch, PCIe switch, to be able to zone any storage or any drive, if you want to call it, to any host. And there are two models that they're going about doing this. So if you look at this carrier, in this one you can either put a 2.5-inch drive, NVMe drive, or you can put two NVMe M.2 drives. I mentioned the densest production NVMe M.2 drive in the world, so those are actually placed in this box. So if I go with the M.2 form factor, instead of a single drive, I get two drives. So I get twice the benefits out of this slot from a capacity perspective, from a performance perspective. So it becomes a very interesting form factor for cloud deployment and for hyperscale deployment, and that's certainly a direction that we see strongly with M.2, and it's a strong play for us at Seagate as well. So the nice thing about this particular solution is that if you add up both the top tray and the bottom tray and use the M.2 NVMe's, you get a capacity of 120 terabytes. Very soon, these M.2 sticks will be offered in 4 terabyte versions as well. So that ends up being a 240 terabyte version. So the previous model that I showed you is one way to put dense NVMe storage together for a hyperscale type model. So people like Facebook and Amazons and Microsofts of the world can create purposeful appliances like that to address what they need. They're also good about putting some of that stuff out, like Facebook puts that whole solution out in the open OCP community, so other people can build solutions like that, and it will apply to a good certain number of data centers, but it's not necessarily universally working for every data center build out there. So there's other ways to deploy NVMe dense storage in servers as well. So another interesting approach to this is what if, one thing that you find plentiful in a lot of servers are PCIe slots. So one model, again, this is something that Facebook is collaborating with us as well, but it's being deployed everywhere, and it's very interesting, is how can I aggregate these M.2 sticks, these NVMe drives, these really dense form factor NVMe drives, and provide an aggregation of them inside a server. So in this one, I'm holding what I call a carrier card, which has 4 of these M.2s. And so a total of 4 M.2 NVMe drives. In this case, if this is our production 2 terabyte drive, it ends up being a 8 terabyte card. So this is a very easy way to put an 8 terabyte NVMe, high performance, low power, all the good things that you get with NVMe in a system. All I have to do is have a by 16 slot available, and I plug it into a server, and you can see in this 1U server there's a vertical connection for it, so it doesn't have to be taking up vertical space. There's also by 8 versions of this, so again, very optimal solution for general chassis out there. One thing that you need to realize is that for the most part, when manufacturers or chassis manufacturers, OEMs and whatnot are putting systems together, when they have front bays for drives, and in this shot you can't see it, but believe me, they are here. You can typically they design it to be supporting both hard drives and SSDs, and in those cases, for the SSD ones, they can take both SATA and HDD, SATA and SAS. So it becomes very expensive if you want to design a backplane here that can support SATA, SAS, HDDs, and NVMe drives on top of it. So it's a cost for them that inhibits putting all NVMe solutions. So in this box, there are 24 drive slots in the front, but typically a manufacturer may give you 2 or 4 of those to be NVMe. So that's why a solution like this makes great sense, because now you can expand the number of NVMe solutions that you have in the system, and that's working out well for a lot of our customers. Okay, so we talked about 2 different deployments of NVMe in systems that are popular out there. We talked about the JBOF model and what Facebook is doing with Lightning. We talked about the adding card and the carrier card and the kinds of problems that it solves. Now we're going to talk about the third option, and I'll refer to some of the chassis vendors that are putting nothing but NVMe slots in their system. So in a system like this, basically manufacturers are making the chassis manufacturers and OEMs. In this case, this is a box from AIC. You'll see a similar one like this from Facebook we have on the show floor, but also there's one from Dell and multiple of them. What they're doing is they're trying to simplify things. So as remember, in the previous model, I told you guys that typically when you make a front-ended chassis like this, these drives have to support both HDDs and SSDs and different flavors of SSDs, SAS and SATA and NVMe, so that's a cost adder. So what they're doing is that they're just offering NVMe slots in the front, and what that will do is that make the overall cost of the system lower. So you no longer have to have bridges, HBAs that support SAS, SATA, all of that is out of the picture. So NVMe drives and those PCIe lanes are directly connected to the host, so that brings the overall cost of this system lower. As you can see here, we have an XF1440 drive. It's an NVMe drive. It goes right in here, and so it's a 7mm drive. Don't be surprised if people design chassis that will take actual 7, in a 2.5-inch tray like this. I can put maybe 2 of these 7mm drives, so this 10 drive system now becomes a 20 drive system. So those are kinds of innovations that we'll see with NVMe. But this model is very popular, and I like to position it almost as a SATA killer. And the way that works is, we've done some studies, and if you take into account the cost of putting a system like this with drives and the CPU and everything else, and throw in the cost operations of the cooling and all of that, it ends up being a cheaper solution to build storage compute platform using a 1U 10 drive NVMe versus a 2U SATA 24 drive SSD system. Okay, so some of the specific examples and work that we did is we took Ceph, which is a very popular software-defined storage that can support both block and object type storage, and it's fundamentally the most popular solution out there for OpenStack, which is a very growing segment in creating lower tier, lower cost storage in almost every data center, every enterprise IT that you see out there. So what we did is we did a comparison of running a fully flash-based Ceph system running on these 1U all NVMe servers versus the 2U 24 drive SATA systems. And we ran a bunch of benchmarks in a real system. We looked at both block size, everything that the drive could do, 10 drives versus 24 drives, but actually from a Ceph perspective. And everything shows that from a performance perspective, we are about 4x better than what SATA 24 SATA drives can do, but more importantly, the overall cost of the system is much better. So with Ceph, you're essentially dedicating one core per drive. So I can get the kind of numbers that I want with my IOPS and quality of service out of 10 cores versus 24 cores, and then I save that budget, that delta from 24 cores to 10 cores, and I can create larger cluster. So what we're seeing with these systems is that the NVMe drives and these 1U type products, they're going out there, people are putting infrastructure together using these drives and this kind of solutions at a much more cost-effective way, and it's really taking away some sockets away from SATA. So NVMe in this space is certainly going to take a good amount of share away from SATA drives. Thank you very much.